Okay, more example. We'll come back. K minus 1, 2k, and 21 minus k are consecutive terms of a geometric sequence. Find k. So we have our u sub 1 is equal to k minus 1. U sub 2 is equal to 2k. U sub 3 is equal to 21 minus k. Okay, and then if you want to find r, then we have 2k divided by k minus 1, and another r is equal to 21 minus k divided by 2k. So if you want to equate that, we have 2k is equal to k minus 1 is equal to 21 minus k divided by 2k. So if we multiply both sides of the equation by, I removed that, by 2k and k minus 1, then we have 2k multiplied by 2k divided by k minus 1 and multiplied by k minus 1 also is equal to 21 minus k multiplied by 2k multiplied by k minus 1 divided by 2k. So this is 1, this is 1. So we have 4k squared is equal to, we have 21 minus k multiplied by k minus 1. Multiplying, we have 21k minus 21, and then we have minus k squared plus k. Simplify, we have 22k minus 21 minus k squared is equal to 4k squared. Then we have, if we add both sides of the equation by k squared plus k squared, and then subtract by 22k minus 22k, and then add 21 plus 21, then we have 4k squared, no sorry, 5 should be 5k squared minus 22k plus 21 is equal to 0. As you can see here now, we have quadratic function, quadratic equation, where we can use factoring if you want to use factoring. This is 5 and 1, and this is negative maybe 7 and 3, negative 3, 15 plus 7. That's very good. Then we have, this is now equal to 5k, and the other is k. And then we're supposed to multiply by 3 there, and then by 7 there. Then we can find negative 22 is equal to 0. So we have 5k minus 7 is equal to 0. Our k is equal to 7/5. Here we have k minus 3 is equal to 0. So our k is equal to 3. Now let's see if we can find our r now. We have already found k is equal to either 7/5 or k is equal to 3. But we need to check if we find r. So we have r is equal to 2 times 7/5 divided by 7/5 minus 1. That should be equal to, this is what I have used now, that should be equal to 21 minus k. That is 7/5 divided by 2 times 7/5. So if I'm going to extend this by 5, so I have 14/5 divided by 2/5, and this is now 14 divided by 2 is 7, and I have 7 there, and then I should have 7 here also. So if I will expand this by 5, then I have 105 minus 7 divided by 14. Oh, sorry, 5th also here, 5th, so that I can remove 5 there. Then I have 77, 105 minus 105 minus 7, that is 98 divided by 14, that is 7. So we have 98 here divided by 14, that is also equal to 7. So that's it. That's all right. It's okay. That's okay. The other one, maybe I need to use another pen here. We have R is equal to, we have 2k, that is 2 times 3, or 2 times 3 divided by 3 minus 1. That should be equal to 21 minus 3 divided by 2 times 3. Then we have 6 divided by 2, and then we have 18 divided by 6. We have 3 is equal to 3. Then we have our R here, which is the same, that is 3. So that's it. This is also all right. Value of k. Okay, another. A geometric sequence has u2 is equal to -6 and u5 is equal to 162. Find its general term. So we have u sub n is equal to u sub 1 multiplied by r raised to n minus 1. So our u sub 1 is equal to u sub 1 multiplied by, that's u sub 1. U sub 2 is equal to u sub 1 multiplied by r raised to 2 minus 1. And then u sub 5 should be u sub 1 multiplied by r raised to 5 minus 1. So we can equate those so that we can find the value of r and u sub 1. So we have now this supposed to equal to 6, and this supposed to this should equal to 162. Sorry, -6. So we have u sub 1 multiplied by r is equal to -6, and then u sub 1 multiplied by r raised to 4 is equal to 162. So since this is a ratio, we can divide those. We have u sub 1 r raised to 4 is equal to 162, and then divided by u sub 1 multiplied by r divided by -6. Then this will become 1. Then we have r raised to 3 is equal to 162 divided by -6. We have -27. So our r now is equal to the cube root of -27 is -3. You need to take the cube root of that. So now we have the r. What is left is u sub 1. But we can use u sub 2. We have u sub 1 multiplied by r is equal to -6. u sub 1 multiplied by negative 3 multiplied by negative 3 is equal to negative 6. If we divide both sides of the equation by negative 3, then we have u sub 1 is equal to 2. Okay? So our un now, u sub n is equal to 2 multiplied by negative 3 raised to n minus 1. Next example, we have here, find the first term of the sequence, 6 times 6, and then we have a sub 1 is equal to u sub 1, sorry, not a sub 1. I am used to u sub 1, I am used to a sub 1, 6, and then u sub 2, we have 6 squared of 2, and so on, as you can see there. That means our r is equal to 6 squared of 2 divided by 6, that is square root of 2. We'll try another. We have 12 divided by 6 square root of 2, that is 2 divided by square root of 2, but if we expand this by square root of 2, square root of 2, then we have 2 square root of 2 divided by 2, then that is square root of 2. Yeah, then we are finished with that. We have our r is equal to square root of 2. Then we have our u sub n, general formula. We have 6 multiplied by square root of 2, someone came, sorry for that, multiplied by square root of 2 raised to n minus 1. Okay, then this is supposed to be our formula by finding 1000, which will be our n when it exceeds 1400. So we have 6 times square root of 2 raised to n minus 1 is equal to 1400, or sorry, greater, it should exceed, greater than. And then if we divide both sides of the equation by 6, then we have a square root of 2 raised to n minus 1 is greater than, we have 1400 divided by 6. If we divide by 2 there, by 2, then we have 700 divided by 3. Okay, and then as you learn from logarithmic functions and logarithms, then we can solve this by logarithm. So we have logarithm of n minus, logarithm of square root of 2 raised to n minus 1 is greater than logarithm of 700 divided by 3. I'll put parentheses there. And then we have n minus 1, this goes near down, n minus 1 multiplied by logarithm of square root of 2 is greater than logarithm of 700 divided by 3. So if we divide both sides of the equation by logarithm of square root of 2, logarithm of square root of 2, that is 1 now, then we have, and then if we subtract both sides of the equation of the inequalities, sorry, by 1, or add by 1, I am not going to do it fast. We simplify. Then we have here n minus 1 is greater than logarithm of 700 divided by 3 divided by logarithm square root of 2. Plus 1 there, plus 1. And then we have our n now is equal to logarithm of 700 divided by 3 divided by logarithm of square root of 2 minus 1. Of course, there is another way of solving this. For example, if you can put the square root of 2 raised to 2 raised to 1/2 instead, then you will, but the answer should be the same. Just another way of solving. And then we have logarithm of, I don't know if I can show you my screen, calculator screen. Let's try. There you go. There is my screen. So we have logarithm of 700 divided by 3. There you go. Divided by logarithm of square root of 2. And you get 15 plus 1, not minus 1 there, sorry. So, plus 1. So we have if 15.7 greater than 16.7, it should be 7. Sorry. It should be greater than 16.7. That means our n should be 17. That's it. If you want to check if when u 17 is greater than 1400. Let's see here our u sub n. What is our, there you go, u sub n is that one, our general formula. So we have 6 multiplied by square root of 2 raised to 17 raised to 16. That's minus 1 raised to 16. Our n is 17. That is 1536. It's alright, that is more than 1400. So our n is 17. In my next video, I will be discussing more example of this type of geometric progression, some problem solving, and also compound interest. So see you there. And thank you for watching, and I hope you learned something, and I hope to see you in my next video also. Have a nice day.